Welcome to the CETEC podcast, your go-to source for everything environmental engineering. Join us as we delve into sustainable industrial practices, exploring topics like wastewater treatment, water purification, solid waste management, air quality control, noise and vibration, environmental impact assessments, and the latest in environmental legislation. Whether you're a seasoned professional, an industry leader, a student, or simply someone eager to make a positive impact, you're in the right place. Together, let's pave the way to a sustainable future, one episode at a time.
Hi, welcome you all back for another episode in our video series where we discuss about environment engineering and particularly to Sri Lankan context. So today we will be discussing another act in Sri Lanka which is responsible for the ambient air quality in Sri Lanka. So this is called as Ambient Air Quality Act of Sri Lanka, and this act was introduced in 2008 and is a crucial part of Sri Lankan efforts to control the air pollution and protect the public health. So this act established standards for various air pollutants and sets guidelines for monitoring air quality across the country. So by regulating the emissions of these harmful pollutants, this act aims to ensure that the air remains safe and clean for all citizens. So Ambient Air Quality Act outlines specific regulations for the permissible level of various air pollutants. So key pollutants includes particulate matter, where we call as PM, so PM10 and PM2.5, and nitrogen dioxide, sulfur dioxide, which means nitrogen oxides and sulfur oxides, carbon monoxide and ozone. So this act mandates the regular monitoring and reporting of air quality to ensure the compliance with these standards. So recently there has been some cases also reported in districts like Kandy regarding the poor air quality. So this Ambient Air Quality Act is really crucial in that sense because it can poor air quality can lead to numerous issues in public health and as well as the environment. So let's look into what are these parameters are. So first I'll start with the particulate matter, the PM. So PM stands for particulate matter and also it's called as a particle pollution. So the term for this term is for a mixture of solid particles and liquid droplets found in the air. So some particles such as dust, dirt, soot or smoke are large or dark enough to be seen with the naked eye, but others are so small they can only be detected using a microscope. So particle pollution includes basically two main parameters. So under particulate matter we measure two parameters basically, which is called as PM10, particulate matter 10, and PM2.5, particulate matter 2.5. So particulate matter 10 is inhalable particles with diameter that are generally 10 micrometer and smaller. So that is called as PM10. And on the other hand, PM2.5 are much finer particles. They are fine inhalable particles with diameter that are generally 2.5 micrometers and smaller. So now how small is this 2.5 micrometers? Now think about like this. So think about a single hair from your head, and the average human hair is about 70 micrometers in diameter, making it like 30 times larger than the largest fine particle. So human hair is 30 times larger than this PM2.5 particle. So you can assume that how tiny it is. So what are the sources of this particulate matter? So these particles come in many sizes and shapes and can be made up of hundreds of different chemicals. So some are emitted directly from the source, such as construction sites, unpaved roads and fields, smokestacks or fires, and most particles form in the atmosphere as a result of complex reaction of chemicals such as sulfur dioxide and nitrogen oxides. So which are pollutants emitted from power plants, industries and automobiles. So what is the big deal with this particulate matter? What are the harmful effects? So particulate matter contains microscopic solids or liquid droplets that are so small that they can be inhaled and cause serious health problems. Some particles are less than 10 micrometers in diameter. They can get deep into your lungs, and some may even get into your bloodstream. So particles less than 2.5 micrometers in diameter, also known as PM2.5, they can directly go into your bloodstream and pose a great risk to our health as well. And of course, these fine particles is the main cause of reduced visibility, or we call a haze, in certain parts of the world. So how does this particulate matter affect the environment? So particulate matter has been shown in many scientific studies to reduce the visibility, and also it adversely affect the climate, ecosystems and materials. So primarily 2.5 affects the visibility by altering the way of light is absorbed and scattered in atmosphere. So with reference to the climate change, some constituents of this ambient particulate matter mixture promote climate warming also, such as black carbon. So while others have the other influences like the nitrate and sulfate. So as ambient PM particulate matter has both climate warming and cooling properties as well. So PM can adversely affect ecosystems, including plants, soil and water, through deposition of these particle matters and its subsequent uptake by the plants, or it is deposition in water, where it can affect the water quality and the clarity. So the metal and the inorganic compounds in the particulate matter have the greatest potential to alter the plant growth also and yield as well, so reduce the yield. So this is related to the outdoor. So what about indoor? So some of the particulate matter found indoor originated from the outdoor, especially the particulate matter 2.5. These particles enter indoor spaces through doors, windows and leakiness in the building structure. So particles can these fine particles can originate inside the buildings as well. They can originate from the indoor as well. The particles of indoor origin includes components derived from the biological sources, many of which are known as allergens. So such as mold, dust mites and cockroaches, they transport and generate this particulate matter. So indoor activities also generate particles as well, including smoking of tobaccos, cooking, burning wood, candles or incense sticks. So these can introduce particulate matter or generate particles matter. Okay. So that is about the particulate matter. Then now let's move into the nitrogen dioxide or nitrogen oxides, NOxes. So this is a gaseous air pollutant composed of nitrogen and oxygen, and it is one of the group of related gases called nitrogen oxides or NOxes. So nitrogen dioxides form when the fossil fuels such as coal, oil or natural gas or diesel are burned at a high temperatures. NO2 can also form indoor as well, where if we burn fuel like wood and gas are burned indoor, again NO2 can produce in indoors. So what are the health effects of this nitrogen dioxide pollution? So nitrogen dioxide causes range of harmful effects on lungs, including increased inflammation, worsen cough and wheezing, and reduce lung function and increase asthma attacks. So in 2022, the review of multiple studies found that the elevated level of nitrogen dioxide as well as elevated particulate matter and sulfur dioxide were strongly associated with the heart and lung disease or heart and lung damage, affected the pregnancy and birth outcomes as well. But the emissions of this nitrogen dioxide will decline as a cleanup of these many countries are adopting cleaner technologies, and now there's a trend of reducing this NO2 emission in future years. So then the next air pollutant is sulfur oxides. This is again primary gaseous SO2, primary component is SO2. So SO2 is formed when again fossil fuels containing sulfur, mainly coal or oil, are burnt, and by the metal smelting and other industrial processes. So highest monitored concentration of SO2 are usually recorded in the vicinity of large industrial facilities. Like if the facility is lacking modern emission control techniques, such as if they have older coal power plants, there's a high possibility of emitting high levels of SO2. And the SO2 can be natural, can be also occurred, like including release of volcanoes, biological decay and forest fires. By these means, naturally also SO2 can emit. So SO2 is also a major source of secondary particulate air pollution. Once emitted into the air, SO2 can dissolve in water, dissolve in water vapor to form the acidic aerosols, and can also interact with other gases and particulate in the air to form sulfates and other particulate matter products. So these sulfate particles can be harmful to human and to the environment, including via acid rain. So these SO2 particles can significantly reduce the visibility via scattering of light, and most noticeable as a milky white haze during afternoon in summer months. This SO2 can be visualized. And then the next air pollutant is the ozone. So ozone is a gas composed of 3 atoms of oxygen, and ozone occurs both in Earth's upper atmosphere, right, and at the ground level. So ozone can be good and bad depending on where it is found. So when at the stratospheric ozone, it is good ozone, occurs naturally in the upper atmosphere, where it forms a protective layer that shields us from the sun's harmful ultraviolet rays. So this beneficial ozone has been particularly destroyed by man-made chemicals, causing what is sometimes called as a hole in the ozone layer. But good news is this hole is now diminishing with the reduction of these harmful gas emissions. Again, the world has been pretty serious about this, and now the hole in the ozone zone has been diminishing little by little. And so, but ozone at the ground level is a harmful air pollutant because of its effect on people and environment, and it is main ingredient in smoke. So when it comes to the smoke, ozone is the main ingredient in the smoke. So ground level ozone is not emitted directly into the air, but created by chemical reactions between oxides of nitrogen, NOxes, and VOC, volatile organic compounds. So by reacting those two, VOC, volatile organic compounds, and the oxides of nitrogen, this ozone can be formed in the ground level. So this happens when the pollutants emitted by cars, power plants, industrial boilers, refineries, chemical plants and other sources chemically react with the presence of sunlight. So ozone is most likely to reach unhealthy levels on hot sunny days in urban environment, but can still reach high levels during the colder month as well. Ozone can be transported long distance by wind, and so even rural areas can experience high ozone levels. So what are the health effects of ozone? Ozone in the air we breathe can harm our health, especially on hot sunny days. When ozone can reach unhealthy levels, people get greater risk of harm from breathing air containing ozone, include people with asthma as well. And so elevated exposure of ozone can affect sensitive vegetation and ecosystems as well, including forest, parks, wildlife refuges and wilderness areas. So in particular, ozone can harm sensitive vegetation during the growing season as well. So the next parameter is carbon monoxide. So carbon monoxide is a colorless, odorless gas formed by incomplete reaction of air with fuel. So carbon monoxide we call as CO. Pollution occurs primarily from the emissions produced from the fossil fuels like powered engines, including motor vehicles and non-road engines and vehicles. So and also the CO emission includes industrial processes such as the processing of metals and chemical manufacturing, residential wood burning and natural sources such as forest fires. And when it's come to the indoor condition, so wood stove, gas stoves, cigarette smoke and unvented gas and kerosene spaces, heaters are indoor source of carbon monoxide. So the highest level of carbon monoxide is typically occurred during the coldest month of the year, when this inversion condition, that means when the air pollution becomes trapped near the ground beneath a layer of warm air, are more frequent. And CO can cause harmful health effects by reducing oxygen delivery to body's organs and tissues. So exposure to lower levels of carbon monoxide is most serious for those who suffer from the heart disease, and can cause chest pain and reduce ability to work and exercise. And with a repeated exposure that may contribute to other cardiovascular diseases as well. So even the healthy people can affect due to high level of carbon monoxide. So people who breathe high levels of carbon monoxide can develop vision problem, reduce ability to work or lean, and at high levels carbon monoxide is poisonous and can cause even the death. So these are the basic parameters which are mentioned in the air quality standards. And if you recall, these key parameters include PM10, PM2.5. So by regulating these two, it will limit the concentration of particle matter produced and responsible for the respiratory health. And NO2 and SO2 limit sets to control the emissions of nitrogen and sulfur compounds, which contribute to acid rains and respiratory issues. And CO, carbon monoxide, limits the carbon monoxide poisoning, prevent the poisoning, and maintain safe air. And ozone is prevent the smoke and related health effects. So these standards are critical to maintain a safe air quality and protecting our public health. So these are the extracts from the act. So they have mentioned the the measuring methods as well, and they have based on the time period they have described the level. So level is for the particulate matter, it is as micrograms per meter cube, and for the gases like NO2, SO2, ozone, and carbon monoxide, they have given the ppm or particulate matter particles per million value as well. And the monitoring period for the gases is mentioned as 24 hours, 8 hours, and 1 hour. Three categories and three different levels are mentioned. For the ozone, there's only one time, like 1 hour value is there. And for the carbon monoxide, they have 8 hour, 1 hour, and any time as well. So these are the main values of ambient air quality in Sri Lankan ambient air quality standards. So then regarding the time of monitoring, if the act says 3 hour average, we have to measure 3 consecutive hours average and through straight 3 hours. And 8 hour average means 8 hourly average, and 24-hour average means 18 hourly average. So if we are taking for 24-hour average, we have to get the 18 hourly averages to take that measurement. And when it comes to the yearly average, 9 monthly average with at least 2 monthly average at each quarter should be taken when we are doing the measurement. So again, Central Environment Authority (CA) is responsible for enforcing this Ambient Air Quality Act, and CA monitors the air quality, ensuring that the pollutant level does not exceed the prescribed standards. And authority has the power to issue directives to industries and local authorities to take corrective measures if the air quality standards are breached. So again, CA plays a crucial role in public awareness as well, in ensuring that air quality regulations are followed. So compliance with this Ambient Air Quality Act is essential for maintaining this public health and environment safety. So non-compliance again can lead to significant environment degradation, contributing to health problems such as respiratory and reduced visibility due to smoke. So this act provides legal framework for enforcement, ensuring that the industries, vehicles, and other sources of pollution adhere to the established standards. Successful compliance can significantly improve the air quality, leading to healthier communities and better environment. So, as a conclusion, we can say that Ambient Air Quality Act is a vital piece of legislation where it plays a crucial role in safeguard of environment and public health. And it is again the responsibility of all stakeholders, including government, bodies, industries, and public, to comply with these standards and to contribute for a healthy environment. So, with that, we will conclude today's episode as well. So, thank you very much for joining with us, and we highly value your comments in the comment section. So, see you in the next episode. Thank you.